Alright, so let's take a look. This is 12.2 in Hawk's Learning. Let me hit pause just for 1 second. Okay, so in section 12.2 there's only 4 questions. This is the 4th one, and it always come in the same order. So if you skip forward to number 4, this is the 4th question, which is a little more in depth, a little more involved. The questions are a little more complicated, and so I was recording a video to kind of help assist you through the process. Alright, so here we go. So step number 1, I'm going to use TI-84. So step number 1, I need to put my data into my calculator to calculate that slope. So pull up my graphing calculator right here. Alright, so my keystrokes are going to be, I'm going to hit Stat. I'm going to choose number 1, Edit. That'll take me into my list 1 and my list 2. And you can see I've already put my data in here, but what I'm going to do is I'm going to go ahead and do it again. So in case you have some numbers in here, just kind of a review of how we get rid of those numbers. So if we wanted to delete these numbers, we can delete one at a time. We can just press delete, 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 delete. But if there's a bunch of numbers, it would take you quite a while. So a faster way is to go up on top of L1. See how L1 is highlighted now? Press clear, and then press enter. And that will clear the list out completely. And then at this point we can go ahead and type those numbers back in. So 1, 0, 1, oops, 1.5, 2, 2.5, 3, 3.5, 4.5, 5.5, and 6. Alright, so remember that when you have your numbers in, you want to make sure that you have the same number in list 1 that you do in list 2. Alright, so now that we have those numbers in, it says we want to find the slope. So to do this, we're going to do a linear regression. Alright, so the process for linear regression is we go back to the stat key, and then this time instead of editing, we're going to go over to calculate. Alright, we have 2 options. We have option number 4, which is linear regression, AX plus B. And then there's also option number 8, which is linear regression A plus BX. In any technical manual, they're going to suggest that you use number 8 or the AX plus BX or the A plus BX instead of number 4. I'm not 100% sure why, what the purpose is on that, but we're going to go ahead and follow what the guidebooks would say, and we're going to use number 8. And so at this point, if you want to make a note that we are going to use 8, let me make my pen looks big, and which is linear regression A plus BX. And what we're going to have to do here in just a minute is we're going to have to make sense of what that A, that B, and that X are. Okay, so with that said, we'll go ahead and press enter. Now, at this point, by default, and it depends on whether you have a newer calculator or an older calculator, by default, list 1 and list 2 go into your X and your Y. So if you don't have this exact screen, that means you have an older calculator, an older operating system. So don't sweat it. By default, your numbers are in list 1 and list 2. If that doesn't happen, then email me and we can kind of figure out what's going on. You have your frequency list of the list, and that's just default is always going to be 1. Don't even put anything, don't change it is what I'm saying. Alright, now I am going to advance this one slight bit here, and this is a piece where you're not required to do this. I'm going to show you how to do this problem without doing what I'm about to say. But if you wanted to go ahead and store the linear regression equation that we're about to calculate, if you wanted to go ahead and store that into Y1, what we can do is you hit vars, you go over to Y-vars. So vars over to Y-vars, we choose number 1, function. And now you'll see that gives us a list of our function names, so we want to store it in Y1, so we choose number 1. So what that's going to do is that when it does this calculation, when I hit calculate now, it's going to take and spit this into Y1. And once again, if your screen doesn't look like this, then don't worry about this. I'm going to show you how to do it with paper and pencil, and it'll be just as easy as it would be with the calculator. So I press enter, and it does the linear regression for me. So with the linear regression kicking out, what we find out is that, and notice that they want us to round to 3 decimal places. Okay, so that means that we have our A value is 66.6895. I went out 4. So when we approximate that, we round that, that means we get 66.690. And the reason is because the 5 rounds the 9 up to a 10, the 10 carries the 1 over to the 8, and that's how we get 690. Alright, our B value, Our B value is going to be 5.766. And it's a 2 at the end behind that, so we can just leave it as 5.766. While we're here on the screen, I'm going to go ahead and write down our correlation coefficient, or determination of coefficient of correlation, excuse me, and that's our R squared. So that way we just have that already on the screen. So once again, I'm going to round it to 3 decimal places. So I'm going to say 0.8889. So once again, we need to round that. So this would be approximately 0.889, because that 9 would make the 8 go up to a 9 itself, because we're rounding to 3 decimal places. All right. So with that said, these are going to be the things that we're going to need throughout this situation. So let's talk about, first of all, what this A means and what this B means and how it ties together. Our answer for number 1 is strictly our slope, and we already have one of these numbers, but I need to help you understand which one's the right one. All right. So we have an equation called slope-intercept equation. So that equation looks like this. All right. The key thing to remember is that the number in front of the x, that is your slope. The name of this equation, by the way, that's a B right there. The name of this equation is slope-intercept. All right, and so that's our slope right there, the number that's in front of the x. So when we look at our linear regression, our number in front of the x is our B value. So that number right there is our slope, because it's the number that's in front of the x. It doesn't matter that B was used here in this equation as B was used there, because variables are variables. They represent different things at different times. What we care about is that our slope is the number in front of the x. All right. With that said, we go on to the next piece. And the next piece is our y-intercept. And so in this case right here, the reason this equation is called slope-intercept is because that guy right there is my y-intercept. The number off by itself is the place that you cross the y-axis. So that means that this guy right here, the A, is our y-intercept. All right, so with that information, we can go ahead and answer part A. So part A, what is the slope of the regression line, or what is estimate the slope of this particular guy? And that would be our B value. So our slope, which is our M, is equal to B, which is equal to 5.766. Part 2. So in part 2 it says estimate the y-intercept. Well, taking our information from our previous slide, we see that our y-intercept was nothing more than our A value, right? So our A value right here, whoops, that's a bad color. Let's get a better color than that. So our A value is our y-intercept. So our A value was 66.90. So we just take that over the next page. Turn that to the next page. And so our A value, which is our y-intercept, is our A value, and that's 66.690. And that's coming from that previous slide. Step 3. Find the estimate value of y when x equals 1. Well, remember, these are not estimated values. This is a data table. These are actually data values that we observed. And what we did was we took these data values, and I'm going to go ahead and go back to slide number 1. We took those data values, and with those data values, we did what's called a linear regression. We found a line of best fit. We found a line that supposedly would fit this data as best as possible so that we could make predictions. So when we found 1, when we were collecting our data, we got out 66 for our midterm grade. But now with our prediction, or with our formula, so once again we have this linear regression line, this line y equals mx plus b. We now know that our slope is, and I got to go back and remind myself because I don't have it written down, 5.766. So our slope is 5.766 times x plus our y-intercept, or our B value, which is 66.690. And that's our regression equation. This is our regression equation. And I'm going to add one more word on the front of that. This is our linear regression equation. This is our line that of prediction. This is our line that we can use, prediction. Something seems wrong with that word. Let's see if I can spell right this time. I know why. Sorry about that. There we go. Who says I can't spell? Alright, so that's our prediction line. So with that, it says, well, what would you estimate? What would your prediction be if x equals 1? So we take our equation, y is equal to 5.766. We insert our 1 in for x, plus 669, oops. And we take that guy, we're going to plug that into our calculator. So we pull up our calculator, I go to my home screen. So remember, to go to home, you go hit second and mode, and you can see that there's a quit right there. That means we're going to go back to our home screen. So I take 5.766 times 1 plus 66.690. And my solution is, when I plug in, when x is equal to 1, I plug in, my prediction will be 72.456. Alright, so that's how we're going to make our estimate. Now, just real quickly, if you wanted to use, if you're becoming proficient with your calculator, since remember I took our equation, and remember how I stuck it into y1? So what I did was I went to my y equals key. So second quit. So I went to y equals, and we had stuck that equation. So if you look at those numbers, they're not rounded, but if you scan through here, you can see there's my y-intercept plus my b, my slope, times x. So that's in y1. And if you remember from previous things in the semester, if we go to our table, which is written right here in blue, so it means we hit second, table, and we go down to x equals 1, we can see there's our answer of 72.456. So once again, that's kind of like the advanced technique to using the technology. Here's the paper technique of plugging the number into your equation that you created. Here we are just using the technology that spit the equation into this spot, which allowed us to go to our table, second graph, that takes us to our table, and which plugs in our 1 for us automatically, and we get the same exact answer. Alright, part 4, excuse me. So part 4, determine if the statement, all points predicted by the linear model fall on the same line is true or false. Well, here's what I'm trying to express to you. Okay, in blue are our data points that we collected. So remember, these are our collected data points. Alright, we collected those. This line right here is our predicted line. That line is this line right here. This y equals 5.766 times x plus 66.690. That's what it looks like once it's graphed on the TI-83, which I'm not going to go into. It's just the concept. We don't have to do this part. That's another piece for another day. But as you can see, these data points don't fit perfectly, but they fit pretty darn well. And the reason they fit pretty darn well is because if we go back to our correlation coefficient, or our determination of correlation, we see that we have a correlation coefficient of 0.889. So we think about this as out of $1. We're at 88.9 cents, or 88 cents out of $1. That's pretty close. That's a pretty strong correlation. So when you go back and you look at like what your data points look like once they're plotted around our prediction line, so remember, this is our prediction line. Once you plot around, you can see that they crowd it very well. They're very close to that line of prediction, and that's what we want. Now, however, that's not what our question says. Our question says, determine if this statement, all points predicted by the linear model fall on the same line. Well, all points predicted fall on the same line. Those are our predicted points. Any point that we choose at this point, any x value that we plug in. So if we plug in x equals 1, that point we're going to get is going to land on our line. If we plugged in x equals 2, that point we're going to get is going to fall on our line. So at 1, I got 72.456. It's going to be right there. If I plug in 2, let's go back to our calculator. If I plug in 2, I get out 78.22. So I go over 2, I go 78. So this is 70, that's 80. So 2 be 78.22. That's really close to be. This is on the line. It's just, the graphics here aren't making it perfect. At 3, we're at 84. So 3, we're at 84, and that's, just a little bit above. So we're right on target. Every point that we predict is going to be on that predicted line. So the answer to this question is true. All right, my video is running long, so let's see if we can't get through this real quickly. Step number 5. It doesn't look like I did any scratch work on this one, so let's go ahead and talk it out as we're looking at it. All right. On step number 5, I'll tell you what, I'm going to hit pause, that way I can make sure I get through the video. Okay, so step number 5, it says substitute the values found in step 1 and step 2 into the equation. We did that. According to, so let's go ahead and write that out. That gave us that equation, y equals 5.766x. And let's cheat. Let's use some technology to do this. Camera, area snapshot, and bing, put it on our clipboard, go back to that page, and right click. Okay, so this is the equation that we took from the previous guy, right? So we brought this guy over, and we're going to make some predictions based upon this equation that we came up with. And what they're saying is, if I pull up my graphing calculator, what this is saying is find the estimated linear, okay, according to the model, if the value of the independent variable is increased by 1 unit, then find the change in the dependent variable y. So what we're saying is this. If we take this equation and we plug in 1, so we take the equation, we plug in 1, so we get 5.766 times 1 plus 66.690. We plug that in and we get 72.456. We take that equation, we plug in, we increase, this is the independent variable, we increase the independent variable by 1, so this is 5.766 times 2 plus 66,960, and that comes out to be 78, excuse me, 0.222. We'll do one more. I take our equation, I increase the independent variable by 1, and I get out 83.988. So let's go back to the home screen. The question is what am I increasing by? Like, what am I increasing by each time? So let's check it out. If I take the 83.988 and I subtract 78.222, I get the difference right there is 5.766. That number looks familiar. And then I take the 78.222 and I subtract the 72.456, I get 5.766. That number looks familiar. I wonder where we've seen that number before. So what they're trying to say is that if I increase by 1, if I increase my independent variable by 1, then what I'm doing is I'm increasing my dependent variable, which is the output. This is my dependent variable. Then I'm increasing it by the slope. By the slope. So in that particular case, the answer is 5.766, which is known as nothing more than the slope, which in this particular case is known as our b value from our original equation. All right. Last part, part 6. Find the value of the coefficient of determination, rounded to 3 decimal places. We go back to our original slide. We wrote that down the first time. There's our correlation coefficient, or our correlation or determination of correlation, 0.889. Okay, so this is a long video. So our r squared, You know, we're coming in at 19 minutes. I'm going to wrap it up under 20. Please go back, watch whatever part you need to, reference any piece to this question, and so that way you can make sure you work your way through this problem successfully and then can have success on the test. Thank you.